and researcher Elena Enseñado, and we're going to present you um, this webinar, which will be in two sessions. Today's session is how local energy stakeholders can prioritize energy technologies in their sustainable energy action plans. And this is organized by the Institute for Housing and Urban Development Studies with kind support from um, local governments for sustainability, the European Secretariat, ICLEI Europe. And of course, is supported by the Intelligent Energy Euro Project's Covenant Capacity. So I would like to go through the session outline with you. We're going to introduce a little bit of the background of prioritization process and process that has been applied. Then we're going to present you some results of an online survey on prioritizing um, criteria and stakeholders for low carbon energy technologies. We're going to present you preferences of different stakeholder groups such as public authorities, energy industry actors, and technical professionals. We'll have a quick Q&A round, and then we are going to present you the overall evaluation of stakeholder preferences and the overall evaluation of low carbon energy technologies as this was determined based on stakeholders' preference. So an introduction on the prioritization process. It's important, as was highlighted by Carsten, to involve different stakeholders in the decision-making in energy planning to increase legitimacy, facilitate learning, and allow inclusion of multiple stakeholders and multiple perspectives and multiple objectives. Stakeholder participation is essential to guarantee success as well as stability of energy supply systems and assure that all stakeholders are involved and therefore any potential conflict will be minimized. In addition to that, prioritization of low carbon energy technologies is quite important step within the planning cycle for sustainable energy actions. In addition to that, when we plan for climate change actions, it's important to take into account multiple objectives and criteria apart from greenhouse gas emission reductions, economic criteria, local environmental criteria, local social benefits, and so on. This is what you see here at your screen is the uh, planning cycle that has been identified by the Urban-led project, also funded by the European Union and led by ICLEI and UN Habitat. And you can see here the different steps for planning for urban low-emission development strategies. Stage 3 is the identification of priorities, and this is where the prioritization process is taking place. There are different ways to prioritize climate mitigation actions or low carbon energy technologies. One of those is the multiple criteria analysis. It's a widely applied methodology that has been used in energy planning. And the main steps of this methodology are as follows. Um, First, we need to define the options, which are the low carbon energy technologies in our case, to define the evaluation criteria and the main objectives and include different stakeholders or actors that they have a stake in related decisions. Then the next step would be to quantify the impact or assign scores of the different climate mitigation um, technologies or low carbon energy technologies. Then to normalize scores, so to translate the different measurement scale in one common measurement scale. Then to weight the evaluation criteria, and there is another stage where the inclusion of stakeholders is important. and elicit their preferences on the relative importance of the criteria. Different criteria might have different importance in comparison to others. So cities might prioritize more local air pollution, for example, greenhouse gas emissions, which is more a global um, issue. And based on the previous steps, and particularly on the quantification of impacts and weight of evaluation criteria, we can determine the final ranking of options, the final ranking of low carbon energy technology. We are focusing on the weighting of evaluation criteria, as we emphasized before, which is the main step where different stakeholders express their preferences against the evaluation criteria. The methodology that we applied to elicit stakeholders' preferences during the online survey was first we introduced an initial ranking of the criteria, secondly a pairwise comparison, and therefore the weights were determined, and based on the new ranking of the criteria, we automatically applied a consistency test, and based on that, stakeholders and users had the opportunity to revise their initial preferences and agree on the final list of preferences regarding the evaluation. We applied this.
Julius, can I ask you to speak directly into the microphone, please?
Yes. Is that better? Is that better now?
Yes.
So we would like briefly to go through the low carbon energy technologies that we selected to evaluate, and those are technologies that could be introduced by 2030. And I'm not going into details on detailed descriptions, but those that we included in our evaluation were the wind offshore, wind onshore, renewable energy, hydropower, solar photovoltaic, biogas, all of those renewable energy technologies. And then we selected some fossil fuel-based technologies such as gas turbine combined cycle, gas turbine combined cycle with carbon capture and storage, nuclear European pressure water reactor, integrated gasification combined cycle based on coal, and integrated gasification combined cycle with carbon capture and storage. Those are all technologies we aim to evaluate, and therefore the first step was to select criteria and indicators to evaluate those technologies. We went through three-step process of selection of indicators and criteria. The first step was based on a desk review, a second one on expert judgment, validation, and refinement of the initial set of criteria. And the third one was based on a survey of different stakeholders that they commented and refined the list of criteria and indicators. The final list and set of indicators to evaluate different low carbon energy technologies is as follows. First, we have economic criteria such as levelized cost, which is investment cost, operational maintenance cost, and capacity factor. Local employment, job generation. Then environmental criteria as CO2 emissions reductions, resilience to climate change and extreme weather events, noise pollution, radioactive waste, waste infrastructure, ecosystem damages, nuclear pollution, land use requirements, fuel use, and the social criteria category, including level of public resistance or opposition, aesthetic functional impact, mortality and morbidity, and accidents and fatalities. The energy criteria category consists of
Stelios, may I ask for the social criteria? It is interesting to note that usually if you build a project, if you plan a project, for instance in the biomass, but also in the wind sector, often you meet resistance or opposition, different opinions, but there is also the level of public support which you can find within rural urban areas. So why have you not included also the positive side of public engagement in this sense?
That is very true, Carsten. What we tried here is to factor indeed the level of opposition, but the lower the opposition, we assume that the higher the support, so to say. So when we worked on building the list of criteria and indicators, one of the main objectives was to have a relatively small list, and therefore we tried certain criteria to integrate in one. So we could assume that the level of support could be a low score on the level of opposition, so to say. So moving on the energy criteria category, we selected, and this was validated to include energy cost stability regarding sensitivity to fuel price fluctuation, stability of energy generation, peak load response, and market concentration on supply. And the last category was on technological related criteria, such as technological maturity, market size domestically, market size internationally, and innovative ability. As you can see, the list of criteria is quite large, but based on the desk review, the list was even larger, and different stakeholders and experts refined this list. So this is the background of the survey study that was conducted, and now I'm going to pass to Elena to present you briefly the results of this study.
Thank you, Stella. Good afternoon, everyone. And as mentioned, we are going to present the results of the study, results of the survey. So we are going to start off with the preferences of local stakeholder groups. Our study involved different local European stakeholders in the urban energy sector. Although we targeted distinct local stakeholder groups from government officials to non-government organizations, we were only able to gather responses from three broad local stakeholders, namely public authorities, energy industry actors, and technical professionals. However, the results of the study show important insights about the value judgments of these local stakeholders, which we will present in a few minutes. So, the first local stakeholder groups are public authorities, who are representatives of the government both at the national and local levels. As you can see on the graph, it shows the average weights that public authorities have provided to each of the criterion. As you can notice, there are criteria that generated more weights compared to the rest. But what does the graph mean? The graph shows that mortality and morbidity is the most preferred criterion among public authorities. This is followed by ecosystem damages, accident fatalities, levelized costs, CO2 emissions, radioactive waste, resilience to climate change, fuel use, waste disposal, and local employment. Understandably, human health and safety are primary considerations. Public authorities are accountable to their local constituents. Hence,
your words are echoing. Could you either speak directly in the microphone or let the microphone not move if you move it?
Okay. Okay, I will take note of that, Carson. Thanks. Okay, so moving on. Understandably, human health and safety are primary considerations. Public authorities are accountable to their local constituents. Hence, it is understandable for public authorities to prioritize mortality and morbidity, accident fatalities, and radioactive waste. Though electricity generation provides invaluable benefits to society, it also carries health costs to citizens. For example, power stations that pollute outdoor air entail health burdens. It is but understandable for local stakeholders and society in general to be concerned about radioactive waste because of the potential, whether likely or unlikely, for catastrophic accidents. Levelized costs, which include the costs for investment, operation, and maintenance, is also a key criterion for local stakeholders. The creation of employment opportunities is of public interest, especially if this is within the agenda of decision makers. As implied in the results, public authorities prioritize public health and safety, protection of natural environment, economic outlays, and local benefits. These are somehow expected as public authorities are mandated to take care of the general population, the environment, and their local finances. On the other hand, the least preferred criteria were market size, potential export, market size domestic, aesthetic and functional impact, market concentration on supply, peak load response, and stability of energy generation. All these, except for aesthetic, functional impact, are energy and technological criteria, which is somehow expected from public authorities. It is interesting to note, however, that aesthetic functional impact is not much of a concern for public authorities, although this could be expected from other local stakeholder groups, such as, for example, local residents or environmental groups. Based on the results, public authorities prioritize protection and safety, environmental concerns, and economic outlays. Overall, public authorities, as expected from their local mandates or agenda, are concerned about the social, environmental, and economic costs, which are all of public interest. They also express least preference for energy and technological concerns. Public authorities are also concerned about the direct and indirect impacts of the technologies in their communities in the short term and for the long haul, which can be illustrated, for example, by their preference for resilience to climate change. At the level of public authorities, and in this case with government representatives, reducing carbon emissions is given high importance. They do have internalized their roles as major players in the pursuit of a low carbon society and in local climate actions. The second local stakeholder group are energy industry actors. These are representatives of electricity and energy associations, electricity producers, and energy agencies. The graph shows average weights of all criteria as provided by these stakeholder groups. Based on the graph, higher weights were given to certain criteria, such as mortality and morbidity, resilience to climate change, carbon emissions, and levelized costs. Based on the results, energy industry actors have high preferences for CO2 emissions, levelized costs, resilience to climate change, mortality and morbidity, employment generation, ecosystem damages, stability of energy generation, innovative ability, energy cost sensitivity to fuel price fluctuation, and noise. The results show preferences for a mix of environmental, social, economic, energy, and technological concerns. Unlike in the case of public authorities who expressed higher preferences for certain criteria groupings, energy industry actors show varied concerns which span different sectors. This could be explained by the mix of stakeholders included in this group, which included electricity producers, energy agencies, and energy and electricity associations. More insights could be drawn should preferences will be elicited from distinct groups within the energy industry sector. The least preferred criteria among energy industry actors were market concentration and supply, market size domestic, land use requirement, market size, potential export, aesthetic or functional impact, and radioactive waste. Energy industry actors express least preference for certain environmental and social criteria, such as land use, radioactive waste, and aesthetic and functional impact. According to studies, land requirements vary depending on the technologies adopted, as well as regional conditions. Also, there has been debate about the aesthetics of current infrastructure of technologies. However, mechanisms are available for the deployment of energy technologies in unobtrusive ways. These preferences for certain energy and technological criteria were also expressed by energy industry actors. Market size, in essence, would be of high consideration for stakeholder groups that look into market conditions, such as, for example, energy companies. Based on the results, carbon emission is considered high priority. It can be concluded that the reduction of GHG emissions is reflected at different levels, be it international, national, and local, and across different sectors from government to energy industry. There is a priority at the European level to bring down the level of GHG emissions, and this is also manifested in the level of cities and municipalities through their local climate actions, and also in this particular case, even among energy producers, energy and electricity associations, and energy agencies. In order to meet the set GHG emission targets, which have been updated recently, this requires coordinated efforts among many stakeholders. The 2030 framework sets an ambitious target of 40% emissions reduction, and this entails a transformation of the energy system. Like public authorities, energy industry actors also have high preference for mortality and morbidity, which shows their concern for public welfare and safety. Also, compared to the other stakeholder groups, energy industry actors provided a relatively lower weight to radioactive waste and has shown higher preference for level of public resistance and opposition and aesthetic and functional impact. Again, as we have previously suggested, we hope to get more insights from distinct groups within the energy industry sector. The last of the stakeholder groups are the technical professionals, who are consultants and advisors, and from the academe or research.
Elena, maybe before we start, I would like to ask the audience if there are any questions or remarks concerning the conclusions given here. So if you would like to say something, please raise your hand. Yeah. Tara, please.
Yes, and I see that there are three groups of stakeholders, or authorities in the industry and technicals, and I miss a very important group of stakeholders, which are beneficiaries. I also miss the impact of energy on time use as a criteria, and access to and control over. When you use energy at local level, you think about decentralization processes, and I also miss the gender perspective here, because there is an unequal use of energy because of different gender roles. For example, we know that women use very lots of metabolic energy, and when they are poor. So what is the contribution of these energy alternatives for combating poverty? That's, in short, my question.
Thank you for those very interesting questions. Regarding the first one, as we stated, we targeted a larger sample of the population and more representative sample of different groups of stakeholders. Unfortunately, we didn't manage to get all stakeholders groups that we wanted, that would allow us a more comprehensive and complete picture and map of different stakeholders among all related actors. Therefore, obviously, as you very well remarked, we don't have the group of civil society, NGOs being part of the study. Therefore, we cannot really present results for this group. And the second question was related to decentralization, if I understood well, right?
Yeah.
So to which extent the choice of technologies contribute a more centralized or decentralized use of energy. This is related, we try to capture partly this criterion. I'll show you on the energy related criterion. This is the market concentration on supply. So this is partly captures the issue of decentralization of energy technologies, which obviously renewable energy, we could have multiple local producers, and therefore we expect, as it was the case, that here renewables will score higher than power plant.
So you include here also the access to and the control over,
This is the
or just a
control,
market?
yeah, the control over and the concentration of energy supply. And you mentioned a third point, if I remember well.
Yeah, and to support the contribution of energy to poverty reduction and also to promote gender equality.
Right. This was not included directly or indirectly in the list of indicators. Of course, this goes mainly for the European level, for cities, the European scale, and not a global set of criteria and indicators. Of course, energy poverty and access to energy is a priority issue on at a global level, and particularly on developing countries. So they would have been relevant to include, of course.
Yeah.
If there are no more questions or remarks at this stage, we can go on with the results and maybe collect the questions.
Yes, Stelios, I think energy poverty is actually a very crucial point also for the European level, maybe not in every country, but for the UK, there are specific studies for the new member states of the EU. Energy poverty is a crucial term to look at. And also for Germany, for instance, last year, 320,000 people did not pay their bills or were not able to pay their bills, and their electricity was cut.
Exactly.
So actually energy poverty is still or should be still on our agenda also as Europeans.
Yeah.
And but maybe we can conclude this also with our perspective. As far as I understood, you're going to hand out a short questionnaire also today.
Absolutely. So that's an absolutely important issue to be included, definitely. And thanks for that comment.
Okay.
Okay, as for technical professionals, as mentioned, these are consultants and advisors, and they also belong from the academia or research. So what do the technical professionals prefer with regards to the different evaluation criteria and indicators? Based on the ranking, technical professionals conveyed high preferences for CO2 emissions, fuel use, levelized costs, radioactive waste, ecosystem damages, resistance to climate change, technological maturity, accident fatalities, stability of energy generation, and local employment. These are a mix of an environmental, economic, energy, and technological criteria. On the other hand, the list preferred criteria were level of public resistance and opposition, aesthetic and functional impact, land use requirement, market concentration and supply, noise, and market size for domestic. As for level of public resistance and opposition as the least preferred criterion, it is widely accepted that energy projects or electricity generation facilities in general need to be supported by the public sector. It could be a challenge for energy projects to be recognized as a public good and not as a commercial endeavor. Comparing the preferences of technical professionals with the other local stakeholder groups, this group also prioritizes carbon emissions. Technical professionals share the same judgments as public authorities and energy industry actors when it comes to making carbon emissions as an important criterion when assessing technologies. One important observation among the results is that they have showed unique high preference for fuel use. Technical professionals generally take into account the use of fossil fuels in energy generation activities and are advocates for renewable energy. Also, they have provided higher preferences for certain energy and technological criteria, such as technological maturity and stability of energy generation. As they have in-depth knowledge about energy systems and tend to look at the technologies in terms of efficiency improvements and performance levels, this could be the possible explanation for the unique high preference for fuel use and their preferences for certain energy and technological criteria. Lastly, they have least priority for certain social criteria, such as level of public resistance and opposition, and aesthetic and functional impact. It is important to note, however, that the two other social criteria, namely mortality and morbidity and accident fatalities, were of relatively moderate importance. As for the overall evaluation about local stakeholder preferences, they have expressed high preferences for certain economic and environmental criteria, which show implied responsibility towards local benefits and negative externalities. The local stakeholders have also high preference for CO2 emissions, levelized costs, ecosystem damages, and resilience to climate change. CO2 emissions was the most preferred criterion by both energy industry actors and technical professionals, while this ranked fifth among public authorities. Local stakeholders value public welfare during project installation and operation. The potential impacts of low carbon energy technologies in human health and safety are considered a priority. Aesthetic and functional impacts seem to be the less preferred and least important criterion. As a brief overview of stakeholders' preferences, public authorities expressed high preferences for social criteria, gave more importance to in ecosystem damages or environmental criteria. They have also provided relatively low weight to certain energy and technological criteria. In energy industry actors showed high preference for mortality and morbidity, although public authorities and technical professionals provided the same weights to radioactive waste. Energy industry actors have a relatively lower weight to this criterion. They have also relatively higher weights to level of public resistance and opposition and aesthetic and functional impact compared to other groups. Lastly, technical professionals expressed high preferences for fuel use. They have also provided relatively lower weights to social criteria, such as mortality and morbidity and accident fatalities compared to the other groups. And they have expressed more preference for certain energy and technological criteria. The graph shows the major discrepancies among the preferences of local stakeholder groups, or the convergence and divergence in stakeholders' preferences. As you can see, the public authorities gave more importance to ecosystem damages. Technical professionals expressed higher preferences for fuel use, while public authorities expressed high preferences for social criteria, namely mortality and morbidity and accident fatalities. Considering the varied objectives of local stakeholders, a shared vision is important in the success of energy systems. Such vision is necessary to streamline local actions, make opportunities clear for everyone, and to set common aspirations. Here are the most preferred criteria among the local stakeholder groups in general. These are CO2 emissions, levelized costs, ecosystem damages, mortality and morbidity, resilience to climate change, radioactive waste, accident fatalities, employment generation, fuel use, and waste disposal. Even at the local level of local stakeholders, taking action to mitigate carbon emissions is on the forefront, which is also supported by the inclusion of the criterion resilience to climate change among the most preferred criteria. High preferences for ecosystem damages and waste disposal show value for the local natural environment and consideration for waste creation and management. Both economic criteria attained high preferences from the local stakeholders. The creation of employment opportunities is of public interest. With the results of this study, however, it is important to note that employment generation achieved relatively lower weights compared to mortality and morbidity as well as accident fatalities, which are two criteria with a social dimension. Also, because of public concern, radioactive waste is a criterion for energy technologies among local stakeholders. Given the preferences of the stakeholders for the different evaluation criteria and indicators, which is the low carbon energy technology that best reflects their preferences? Is it wind, solar, hydropower, biogas, among other options? Through the assessment of low carbon energy technologies based on the weights derived from local stakeholder preferences, it was found that the highest ranked low carbon energy technology is wind offshore. It is followed by solar PV, hydropower, wind onshore, and gas turbine combined cycle. These are the technologies that best reflect the preferences of local stakeholders. As shown by other studies, wind power is also the most preferred and appropriate option among alternative energy sources. IGCC with CCS and IGCC were the least significant low carbon energy technologies. Renewable energy technologies such as solar, wind, and hydropower outshrank other groups of technologies such as fossil fuel-based ones and nuclear technology. Considering the costs, specifically the levelized cost, this results to a different ranking. European pressure water reactor outperforms other technologies. This is followed by fossil fuel-based ones. And lastly, the renewables were the least performing technologies. The values used for the cost-based assessment were drawn from IEA projections and economic analysis.
Here I may ask, because the renewable energies are, as far as cost effectiveness is concerned, rank quite low. Has the study on which you took this ranking or based this ranking upon, does it include indirect subsidies for coal or nuclear or fossil fuels?
Carsten, I think here what we see is that based on the IEA study projecting the costs of different technologies, we see clearly that coal and fossil fuel-based technologies and nuclear power have less costs when we don't take into account other criteria, other aspects, other objectives, such as environmental, health, social, technological, and so on. So that's why we think that it's quite important in decision making, not taking decision or basing our decisions only on the cost criterion, but also going further to explore which are the implications and impacts of technologies in all other related aspects, and to which extent those aspects are weighted and evaluated by the different stakeholders and groups that will be affected. So that's why we have included this figure, this presentation of the results from the IEA study. And to
I think it's
Mhm.
I think it's always important, to compare, of course, not apples with pies, but or pears. But it is, I think, important to know exactly upon what we are discussing and where what we base our cost assessment upon. For instance, Elena
Right.
mentioned also the new target for the 2030 framework of the European Union, the energy and climate package, and said that 30% to 2030 is ambitious. From my point of view, it is not at all, and also scientifically, it is not sufficient if we listen to the IPCC reports and recommendations. However, the European Union explains the 30% as being the most cost-effective solution and option for us. However, does not in their calculation, as far as I have understood and actually also asked for, have not included the costs of adapting to climate change, as well as no health implication costs. So that is why, and I think this is a good example why we should always look at what is the basis for the cost-effective analysis. And in this sense, renewables, I think, are leading us to a different picture. And yeah, but this is just a side remark. Thank you.
Thanks, Carsten. I think it's an important remark, and I think this study really coincides with what you're saying, that just cost or even cost effectiveness is not always the right tool to take decisions. And what is important also is to know what we include in the criterion of cost. Because here, based on the IEA study, we are talking only about the levelized cost, which means external costs, adaptation costs are not included, which are somehow included in the survey and study that we conducted by including all those different aspects and objectives. And based on the results of the preferences of the three different groups, we can see here the ranking, the final ranking of the different technologies. And you can see that those results here are quite robust. And in all three groups, we clearly see that renewable energy outperforms all the other technologies, outperforms nuclear power and fossil fuel-based technology. So I will continue with some implications of the results of the study. As I said before, we have quite robust results, a small difference in the overall ranking of low carbon energy technologies among the local stakeholders groups. And this, as you very well remarked, could show us that we should take into account in the policy making to stimulate more renewable energy technology by introducing policy measures, which I would say comes in contradiction with the current reality. Now that we are facing also economic crisis, we have seen a new proposals to reduce feed-in tariffs for renewables and for solar PV, or even proposals to tax solar energy generation from solar rooftops, for example. Another comment based on the results will be that we think that it's important to include stakeholders' judgments and preferences on when we decide on which low carbon energy technologies or which energy technologies to implement. And this is an important exercise that could help us to map the different preferences among stakeholders and see main differences between their preferences, but also identify potential conflicts. And even such kind of process could guide us to resolve potential conflicts and preference differences. And I would like to ask you if you have any questions or remarks so far before going to present you briefly the tool that we're going to send you and use at the next session, in the more interactive session that we will have more discussion and use the tool that we're going to share with you. So please, if you have any questions, I see one hand here. Is that right?
I think Tara used her hand already, but she might have a second question. Please, Tara, do you have another question?
I was wondering, who are local stakeholders groups? These three stakeholders, authorities, industry, technicals, are they considered to be local stakeholders groups? Or do you have other local stakeholders groups?
For this survey, having a small sample, those stakeholders are local stakeholders.
But you mean by local, national, or what do you mean by local?
We mean more related to local, to cities actually.
To?
To cities, provinces,
Cities. Okay.
and so on.
Cities. Okay. Yeah. Thank you. That was my question.
Yeah. If there are no...
There's one more question from Nikki Mises. Yes, please.
Just wondering how prioritization is actually being conducted. What do you mean by prioritization? You mean implicit prioritization or official prioritization within the formulation of action plans? And what does that mean? Does it mean a different level of support, which is formulated by public authorities and then drafted and enacted into national law? Do you mean, so prioritization is the favorableness expressed in political support and level of support?
Thanks, Nikki, for your question. What we mean here by prioritization, we mean prioritizing the different technologies based on the preferences of stakeholders. So
okay.
That's the idea, that we include the preferences of stakeholders, and based on that, we prioritize, we rank the different technologies.
Okay, so there's an implicit prioritization being made at the process of policy making.
Right.
Okay. Okay. Thank you.
There is one more question from Yusuf.
Yeah. Thank you for the presentation. Going back to one of your slides, you made mention of solar power generation being the lead of power generators in the European Union. I was looking into it a little bit differently. That what about if if the technology can be transported into other communities where you have more solar power generation? I guess the reason for that in Europe is because of the
afraid it's not very clear. I cannot really hear.
But if you hello.
Yes, please.
Hello?
Go ahead. Try once more. Yeah.
Once more. Okay. Going by one of the slides, you made when you prioritize the amount of energy generation based on the technologies that you use, the gas turbines were the highest generation, which is natural, and the solar panel. Well, what my opinion is that yes. Can you hear me?
It is very hiccuped. I would suggest that you just write quickly your question in the chat box, please, or use the question box, and I can read it out.
Okay, I'll do this.
And in the meantime, I might say that actually it reminds me very much of a workshop I've been to and supported. I supported a city here in Germany where the energy provider, together with the city, planned a biomass plant to produce renewable energy and to move ahead with the climate targets of the city. Now, the energy provider has looked and planned the plant just simply from the economical perspective of where can he get resources from the regional area. So he wanted to make this regional emphasis as well. So nothing wrong with that. And he looked at where to place the plant in the most cost-effective way, not thinking about the trucks of the biomass supply going through, well, using different streets which were quite residential. So based on his assessment, it was economically totally viable. But from the social point of view, of course, then there was an uproar. And I think this example is quite interesting and points us points out exactly what we are discussing today, that not only the economic evaluation and assessment is important, but also the social criteria as well as the environmental.
Okay. Thank you for your comments and questions. Then, since we are running out of time, I would like to run through the next session that we're going to have on Wednesday and briefly introduce the tool that we're going to share with you, and we would like to ask you to fill it in, and then we're going to collect the information and data from you on Wednesday noon, and have a discussion based on that. So the next session that will be held on Wednesday will focus first on the overview of the interactive preference elicitation process that we're going to run together. Then we're going to present the results of the data and information collected from your preferences. Then we will like to have a discussion based on your initial preferences to see where are the main differences to justify preferences, to stimulate discussion and interaction, to share information and knowledge, and then again reiterate or actually revise your preferences based on the discussion, and see if there are any similarities, if we have minimized the differences, if we have generated knowledge and shared valuable information in order to move to a more solid and justified expression of preferences on evaluation criteria of low carbon energy technologies. So I would like briefly then to go with you through this tool that we're going to send you directly after the end of the session. I would like to share my screen with you. Yes. I hope that you are able to see my desktop now. So the first spreadsheet requests the participant, the user, to fill in the information about his or her profile. Then there are some background information related to the description of low carbon energy technologies. Then some information, background information on the type of criteria that have been used for the evaluation. Step 3 summarizes results from different studies on the impact of different technologies against our criteria. And the main part of the questionnaire starts at step 4, where we present the lists of evaluation criteria, the unit of measurement, the worst performance value, and the best performance value based on the impact matrix that we showed before. Then the potential improvement, which is the difference between the worst and the best performance. And you are requested at this stage to identify the level of importance of moving from the worst performance, the worst scenario, to the best one. So by doing this, we really try to highlight the importance of potential improvement. Therefore, you are requested to look at that and decide the level of importance from low to moderate for each criterion. So you have those 3 options. I very quickly could fill arbitrarily those cells in order to go on with a demonstration of the tool and how to fill that in. The idea of breaking down between high, moderate, and low is to reduce somehow the burden on the respondent and being able to compare and see the criteria in smaller groups. So after filling in the level of importance of the different criteria, we move to the next step, where we look only at those that they have been selected as high importance criteria. So we click and we select only on high important criteria. And the question again is, if we assume that all our criteria are at their worst level, which one would you select first to move at the best performance level? So we see, for example, the potential improvement, which is the difference between worst and best, which is measured in grams per kilowatt hour. If we think that this is the first criterion that I would like to move from worst to best, then I type 1 as first ranked criterion. And I do the same for the rest of the criteria. If I think that accident fatalities is the second most important to move, we see number of deaths that would be improved moving from the worst to the best performance, then I would select waste disposal at 3rd, level of public resistance as 4th and 5th. Now I'm doing that quickly for the sake of the demonstration. We do the same for the moderate level of criteria. So we select moderate, and we perform the same question, which, assuming that all criteria are at their worst level, which one would you select first to move from the worst to the best level, as we did at the previous spreadsheet? So we could very quickly do so here, like first ranked, I put values arbitrarily again, second, third, it doesn't really matter.
I think that's fine. Stelios,
Yes.
we got your idea. Yeah.
Yes, I think, and then we move on with the same logic for the for the low level of criteria, and at the end we request, based on the ranking that has been produced, to give values of relative importance to the criteria. And at the end, we will have a graph which is not displayed now, but it will be displayed if we fill in the values of relative importance. And at the end, we would like to request you also to fill in a survey evaluation. We are going to share. Is this the right way to stop sharing? Yes. We're going to share this Excel tool with you, and we would like to request you, if possible, to fill that in and send it to us on Wednesday, by Wednesday noon. So it will be great if we have all results, all your data by 12, that we will be able to process them and present them on the webinar session 3 o'clock and discuss them. So I think, Carsten, at this point we could stop here. I think we are running out of time. And please, if you have any questions, if you have any urgent questions, we can address them now.
There is one question from Musuf in the chat box posted to you. I leave it to you if you would like to answer that now, or also you can send him an email if you want. So please decide.
I cannot see it.
Okay.
Is this from? I can't find it, Carsten.
Okay, no, I see it. It was posted privately. I will send it to you. But in the meantime, also Tara has a question. Tara, please.
Yes, I was typing it. I was wondering, we are now 10 people, and we can influence these data. So how much can we influence them? How many respondents did you have from how many countries to achieve these data? And where are these data used for?
Okay,
Did you?
thank you.
Yeah.
Yes, thank you, Tara. The idea would be that we are going to receive those data from you, from the participants of this session, but also other respondents that they have complete the registration form, and those are again representatives of energy related stakeholders, particularly at the local level. And this will be an exercise that we are going to run on Wednesday. And the idea will be to discuss based on the initial results and generate and stimulate discussion, share knowledge, share information, and revise the initial preferences. So
yeah, and my question, how many respondents do you have so far?
So far we have around 15 to 20 respondents, and of course we aim for more in order to have more representative sample. And this would be a demonstration also of how an interactive process could change the preferences of stakeholders, and by group, by having group preferences, better refine those preferences and results.
But how many stakeholders together did you interview to get these data? how far, what was the response to your survey among the 3 groups of stakeholders?
Right. As I said before, there were like 15 to 20, so we were aiming.
Okay, yeah, then I understand. No, I thought it were more. Yeah, but I thought the 50-20 were people who responded to the stakeholders.
Right.
Okay, but so the data that you have presented us about the priorities of the authorities, the industry and technical people,
right,
are the result of 15 to 20 responses to survey.
Correct.
Okay. Yeah,
and now, with this exercise on Wednesday, we aim of really reflecting on those initial results, and by including a more interactive session on that.
Okay, I understand. Yeah.
So we would really appreciate if you could fill in the questionnaire tool that we are going to send to you now, and further discuss that on Wednesday. So to really interact and see differences and commonality.
Yeah, and then the other question: what is done with the results of this?
The idea would be.
Yeah, I had the impression that it influences the assignation of funds of the European Commission. Is that right?
No, this is not right. It's not that high influential level. This is more for advocacy and dissemination of the results. So we are going to present the results, to publish the results, and then we will leave it up to there. We are not going to really include to be included in a real allocation of funds depending on the results and so on.
Only advocacy.
Yeah, and dissemination. Advocacy, dissemination, and also the learning aspect that this exercise might have. Yeah.
Okay, thank you. Thanks. That's my.
Yeah. Thanks a lot for your questions and comments. So here are our emails in case you have further questions. We are going to receive the Excel tool, and we would like to again kindly to ask you if you could send it to us by Wednesday, 12 afternoon, and hopefully we'll see you, or actually we'll hear you all in a more interactive session on Wednesday. Carsten, I don't know if you have anything else, and if you would like to close.
Of course, thanking you and all participants to join that have joined us. I think advocacy isn't, as a climate policy officer, naturally, I understand this point of view. Advocacy is an important issue here, and if your study brings us, or your questionnaire brings us one step further, I'm looking forward to it. I'm looking forward to the tool, and also to see you again or to hear you again on Wednesday afternoon at 3 o'clock. There was one more question, but I think we can answer that maybe as in the right mood of interactiveness at the beginning of our session, of our next session. So I'm looking forward to meeting you all there once again. Have a nice day, enjoy, and talk to you soon. I will unmute everyone to say goodbye, so we have an inter-actual chat once again. Goodbye.
Okay.
Goodbye.
Goodbye. So
Thank you. Bye.
Thank you.
So, Elena, I look forward to getting the response to my question in the next session. Right?
Absolutely. Absolutely. We'll do so.
Okay. Thank you very much.
Thank you.
Bye.
Yes? Elias, Elena?
Yes, Carsten.
Yeah.
Can you hear
Okay,
us?
I just want to chat with you or to talk to you afterwards. Yeah,
Great.
I found it interesting, your study. I hope that people will respond.
Me too.
And yeah, and then let's see on Wednesday how it functions. But so far, the way of how the webinar went, I found good. What was your impression?
Yeah, also, I think was positive. It seems that I think it's a topic that is of interest for different actors in energy planning. And to tell the truth, if we could really achieve of having, more participants next session will be great on one hand. On the other hand, I understood that the session could be very interactive, which is very good, and I think this will add really real value at the next session. So now it was more like questions and answers, but I think the next session on Wednesday, even if we have like 11 participants as we had today, we could have a meaningful discussion, interactive session, and this I think could bring value also on the whole process, and also like revising the initial preferences and um, agreeing on certain preference values
Yeah.
and result in a solid evaluation.